All right, guys, today we're going to graph quadratic functions when they're in standard form. The standard form of a quadratic function, we're going to graph it, and it's not going to be bad at all. First of all, what is a quadratic function? A quadratic function is one in which there's an x squared, and standard form has ax squared plus bx plus c, which means it usually has an x squared term, an x term, and just a constant term with no x. Every time you graph one, it's going to be a parabola. If we figure out what a parabola is like, it's a U shape, either going up or going down. Parent function for a quadratic is this right here. It's just f of x equals x squared or y equals x squared, which means your vertex is at 0, 0. You would go up 1 over 1, up 1 over 1, and you would graph your parabola right through those points. The vertex, a big deal, is either the lowest point or the highest point. That's going to be later, very important later. It has the axis of symmetry. We don't always draw that, but there's an axis that goes right down the center to the vertex of every parabola because the parabola is symmetric across that line. Let's see what else it says here. For f of x equals x squared and any other quadratic function, the vertex lies on the y-axis. Oh, where b is 0. Yeah, so the parent function does. Okay, we'll graph another one here. It says graph y equals 2x squared. Remember we talked about this a while back. Number in the front means it's a vertical stretch by 2. So I'm going to start, there's no shifting in here. There's no left, right, up, down, so my vertex is still at 0, 0. And remember the last one, just the 1x squared, I went up 1 over 1. This time if I were to plug the number 1 in there and squared it, 1 squared is 1 times 2 is 2. So if I put in 1 for x, I'm getting 2 for y. So I'm going to go 1 over 1 up 2. And if I put in negative 1 for x and square it, it becomes positive 1 times 2, so which is 2. So if I go to negative 1, it's also 2. And then my parabola is just going to get a little skinnier, which is what should happen. It's a vertical stretch like we talked about a while back when we graph things. Number in the front, bigger than 1, is a vertical stretch. Let's look at this one. This one's got two things going on. First of all, it's got a plus 3 on the outside. You know what that means. That means it's been shifted up 3. So I'm going to go up to 3. Instead of starting my parabola at 0, 0, this one's going to start at 3, the vertex is. There's no sideways shift, just a plus 3. There's a negative in the front. Remember what that does? That's a reflection across the x, which means it's going to go down instead of opening up. And the 1/2 is going to be a vertical compress, which is going to make it fatter. So let's do this. Let's plug, I don't know. We need to plug an even number in so that 1/2 will cancel. Let's plug 2 in there for the x. 2 squared is 4. If I take negative 1/2 of 4, I'll get negative 2 plus 3, which is 1. So if I plugged in 2, I got 1, which is right there. And let's plug in a negative 2 and watch what happens. It should be the same thing because it should be symmetric. So if I plug in a negative 2 and square it, it's positive 4. And again, if I take negative 1/2 of positive 4, it's a negative 2 plus 3. So same point, other side. It will always be that way because it's symmetric. Really, I had to plug that in one time, to be honest with you. And remember, the parabola is opening down because there's a negative in the front. Should look just like that or very close. Not too bad. All right, some properties here of standard form of graphing these things. First of all, we can find the vertex. They're going to move the vertex around on you. And when it's in standard form, there's no shifting. Like you can't tell where it's been shifted because there's no parentheses or anything, but there are a few things you can tell for sure. One of them is if the first term is positive, it's going to open up. If the first term is negative, it's going to open down. So that's all about the x squared term. If a is bigger than 1, it gets skinnier or narrower. If it's less than 1, it's going to get wider. That's that vertical stretch and vertical compress we talked about a while back. Remember the gesture. The axis of symmetry is the same as the x coordinate of the vertex, the exact same thing. And we're going to find that by using that little formula right there, negative b over 2a. And remember, the b is what's in front of the x. Look up here. The b is in front of the x. The a is in front of the x squared. I'm going to do negative b over 2a. That's going to give me the vertex every time, or the x coordinate of the vertex. Also, the last thing here is very important. The y-intercept is c. The number that sits over there, just the number by itself, is the y-intercept. That's where it's going to cross the y-axis, which is going to mean a whole lot to us as we start to graph these. And that is true because the way you find your y-intercept is you put 0 in for x. So if you put zeros in for all the, for the x's, all that's going to leave is the c. And that's why it's the y-intercept. So I'm going to graph a couple for you and let you see how this works. And I've already done the math part. I'm going to talk you through it just to make the video a little quicker. Hopefully it makes sense without you actually seeing me go through. Then I'll graph it for you, live. So here's my equation, standard form. I need the vertex to be able to graph it. Remember the vertex, the way you find the x-coordinate is you do negative b over 2a. B is right here. I guess I could write on top of that. That's your A, that's your B, that's your C. So I did negative B. It's already negative, so that means you change the sign. You make it positive because negative 8 is really positive 8 over 2A. A is 2, so 2 times 2 is 4. If you do 8 divided by 4, that gives you 2. Now that 2 right there, that's the x-coordinate of your vertex. That's why I put it right down here. Now to find the y-coordinate, what you have to do is you've got to take that 2, and you've got to plug it in your original equation. And if you plug that in, this is what I did right here. That's what this blue stuff is. I plugged it in up there, wrote it all out, worked it out, got negative 2. That's the y-coordinate. So what I can do now is I can come up here and graph. There's my vertex. I know another thing for sure. My A is positive 2, which means I know it opens up. I know that for sure. And the last thing I know is that C term right here that I'm circling up there, that's the y-intercept, which means it's going to cross the y-axis 1, 2, 3, 4, 5. That's 6. Now here's the cool thing. I'm going to make you graph 3 points. There's 2 of them. The third one is going to be the reflection, or I'm going to use the symmetry. The axis of symmetry, if I were to draw it, would come right through here. Right through the vertex, right down the center of my parabola, which means the other point must be right there. It's got to be the same distance away. That's why the y-intercept is so important. It's going to be the same distance away from the axis of symmetry or the vertex. So now I can just graph my parabola. I'm going to have a hard time freehanding this. It's going to do something like that. One isn't too bad. And the other side's going to come up just like that. What I'm really looking for your parabola. The axis symmetry helps, but I'm looking for your 3 points. So I'm going to show you one more. Make sure you got that. Did the same thing here. I went ahead and worked it out, but I'm going to talk you through one more of these things. To find the vertex, remember we're going to do negative b over 2a. There's my b. It's already negative, so if I go negative 2, that's really positive 2. That's why I put the positive 2 right there. Over 2a. A is 1 this time. 2 times 1 is 2. So 2 over 2 is 1. That's the x-coordinate. I put it right there. That's the x-coordinate of my vertex. To find the y-coordinate, you take that 1 and you plug it in up here. Everywhere you see an x. That's what this line is right here. I just plug that x-coordinate in, work it out, got negative 2. That gave me my y-coordinate. So 1, negative 2 is my vertex. So my vertex is right here. I know it opens up because that was a positive x squared. And I also know this last term right here, that's my y-intercept. So my y-intercept is negative 1 right here. Now, again, if you were to draw your axis of symmetry, it always goes right through your vertex. And that helps me because that means there's another point right there directly across the axis from my y-intercept. And now I can just draw my parabola, connect the dots, like that. And that's it. That's all you got to do. Hopefully that makes some sense. So 3 points, good to go. One more thing here. The last thing they're going to ask you to do today is find the max or minimum of a function, of your quadratic. The vertex is always either at the bottom or at the top, which means your vertex is the max or the min. But the only part that you want is the vertex's y-coordinate. So you got to find the y-coordinate. Now, if it opens up, it's going to have a minimum. If it opens down, it's going to have a maximum. All right, so if A is positive, it has a min. A is negative, it has a max. And you want the y-coordinate of the vertex. So you don't have to graph this. You just got to find the y-coordinate. So let's go one more slide. Let me show you how we do that. Okay, so it says this. Tell whether this function has a min or max, then find the min or max value, which remember, that's the y-coordinate. So first of all, I know this. I know my A is positive, which means this parabola opens up. And because it opens up, my vertex down here, that's a min. So I knew right away it was going to be a min. Now the minimum happens at the vertex, and all I want is the y-coordinate. So the bad news is you can't find the y-coordinate unless you first know the x-coordinate. So I did my x equals negative b over 2a again. 18 was my b. 3 is my a. And worked it out. I got 3. Now that 3 is good, but it's not an answer. But what I'm going to do with the 3, remember like we did the last few slides, I'm going to plug it back in. And that's going to tell me, because look, y equals all this stuff. So if I plug 3 in for the x's, it's going to tell me exactly what y equals. So here's my work where I plugged the 3 in. and I worked it out and I got negative 25. That's what I need, is that negative 25. The negative 25 is my min. And again, it's a min because it opens up, because A is positive. And that's the lesson for today. I don't think that's that bad. A lot of quadratics, we'll work on it tomorrow like we always do. And can't wait to see you then. See you, bye.